Welcome to today's lecture on cooling load calculation presented by Dr. Sam Tawfiq. In this session, we will explore the essential concepts related to cooling load calculations in refrigeration applications. Lecture objectives. Before we dive into the calculations, let's review our objectives for today. By the end of this lecture, you should be familiar with the methods used to calculate cooling loads in refrigeration systems. This knowledge is crucial for effective system design and energy efficiency. Cooling load calculation. To understand the overall cooling load, we use the formula Q total equals QT plus Q sun plus QP plus QA plus QS. Here, QT represents the transmission load, Q sun is the sun load, QP refers to the product load, QA is the air change load, and QS is the service load. Each of these components plays a vital role in determining the total cooling load required for a refrigeration system. Transmission load calculation. Let's focus on the transmission load, QT, which can be calculated using the formula QT equals the summation of U times A times delta T. In this equation, U is the overall heat transfer coefficient measured in watts per square meter per degree Celsius, A represents the area of the wall in square meters, and T is the temperature difference between the inside and outside. Understanding this calculation helps us assess heat loss through building materials. Sun load calculation. Next, we calculate the sun load, Q sun. This is determined by the equation Q sun equals Q ceiling plus the sum of Q for two walls. Alternatively, we can express this as the summation of U times A times delta T sun. Here, delta T sun is derived from solar intensity, surface absorption, and the outside heat transfer coefficient. Each factor is crucial for accurately estimating the heat gain from solar radiation. To calculate delta T sun we have capital I, solar intensity, measured in watts per square meter, watt, m, alpha, surface absorptivity, which depends on the wall color H0, the outside heat transfer coefficient by convection. Finally, the relationship delta T sun equals alpha dot I divided by H0. Product load calculation. Now, we will look at the product load, which is vital in refrigeration. The factors involved include product mass, cooling time, and specific heats for states above and below freezing. We also consider the initial and exit temperatures of the product, the freezing temperature, latent heat of freezing, and heat of respiration for life product. Together, these elements determine how much cooling is required to bring products to their desired temperatures. Let's review the key terms from this slide. MP, product mass, cooling time, CAF, specific heat above freezing, CBF, specific heat below freezing, TI, initial temperature, TE, exit temperature, TF, freezing temperature, L, latent heat of freezing, Q respiration, heat of respiration for living products. Air change load calculation. Moving on to the air change load. This calculation is based on the number of air changes per day and the volume of the cold storage area. Proper ventilation is essential for maintaining product quality, and this calculation ensures that the system can handle the required air exchange effectively. Service load calculation. In this slide, we cover the service load, which is composed of three main components: light load, workers load, and motor load. The total service load, QS, is the sum of these three factors. Understanding the service load is crucial for designing lighting and operational strategies that complement the cooling system. Evaporator capacity. Finally, we will discuss the evaporator capacity, which is critical for system performance. The formula involves the evaporator capacity, the number of evaporators, machine working hours per day, and a safety factor. This calculation ensures that the system operates effectively and safely under varying conditions. Conclusion. In conclusion, we have covered the key components of cooling load calculation, including transmission load, sun load, product load, air change load, and service load. Each component has its own significance and contributes to the overall efficiency of refrigeration systems. Thank you for your attention, and I look forward to answering any questions you may have. With my best regards, Dr. Sam Tawfiq.